Recently, we've calculated velocity as distance divided by time. So for instance, if it did 100 miles in 2 hours, you've gone on average 50 miles per hour. And most of us can visualize that and understand what that means. Well, acceleration is quite a bit different. Acceleration is kind of a momentary or instant reading. So on any journey, at any one time, the acceleration can change. Even between two stop signs, say they're a mile apart. During your entire travel down that road to the other stop sign, your acceleration can change from 0 to a positive great value to a negative value. It varies at each point along the trip, but it can still be calculated. So the formula says it's the change in velocity over the time for that change. The way we're going to use it will be acceleration equals the final velocity, wherever we are at the end of the time period we're talking about, minus the original velocity divided by time. You might want to write that formula down because that's what we're going to use for this whole page. So let's try some examples here. Number one, a car's velocity changes from 2. Now, ignore the pluses and minuses. I had an idea with that, but we'll ignore the pluses and minuses on these couple problems. But this is the original. It's from. It goes to 10 miles per second. This is the final. And in 4 seconds, that's the time. So we'll just plug those values into the formula. So it's 10 minus 2 divided by 4. And that's 8 divided by 4, or just 2. And the units is meters per second squared, but it's a positive 2, so it's accelerating. Just going to get rid of my work here so we can have a clean slate. Number 2, car's velocity changes from 10 to 2, so it's going from originally 10, this is the VO, to 2, the final. So the final is slower than the original, so it should be a negative number. And it's the same 4 seconds we just had. Looks like the numbers are just reversed. So the final's 2, so it'd be 2 minus 10 divided by 4. And it's negative 8 divided by 4, or negative 2 meters per second squared. It's negative. It's decreasing. It's slowing down. Number 3, from 2 to 10. Oh, these are the same numbers. Okay, well, yeah, again, I was thinking of something with these negatives, so we're going to ignore these particular problems here, numbers 3 and 4. They're the same numbers anyway. We can go on to the next couple problems. Number 5, you are sledding on a snow-covered hill at a speed of 6 meters per second. So, telling you you're doing it, that's my original velocity. There's a drop that increases your speed to 12 meters per second. That's my final velocity, 4 seconds. So 12 minus 6 divided by 4 equals 6 divided by 4, or 1.5 meters per second squared. 1.5 is positive, it's going faster. You may want to pause if you want to write any of the numbers down. Number 6, you're snowboarding on a snow-covered hill at a speed of 8. That's my original, VO. There's a drop that increases your speed to 14. That's the final. 3 seconds, there's your time. So it's going to be 14 minus 8 divided by 3. 6 divided by 3, it's 2 meters per second squared. Again, it's increasing speed. Number 7, the roller coaster you're on is moving at 12 meters per second, original. 7 seconds later, it's time, there's a loop-loop and it's traveling 26 meters per second. That's the final. What's the roller coaster's acceleration? So 26 minus 12. So 26 minus 12 divided by 7. That's 14 divided by 7. Again, 2 meters per second squared. It's a positive value. We're going faster. Next one. The water ride you're on is moving at 14 meters per second. Original. 5 seconds later, time. It's moving at 16 meters per second. Final. Here's the math. So it's going to be 16 minus 14 divided by 2. 2 divided by 2, 1 meter per second squared. It's accelerating, not as fast as some of the other ones we did, but still accelerating. Number 9, the truck you're riding is slowing for a stoplight. It was initially traveling at 20 meters per second, original, and comes to a stop in 10 seconds. This is the time, 10 seconds. Well, what's my final velocity if you're coming to a stop sign? Well, if you're stopping, your final is going to be 0. So this will be 0 minus 20 divided by 10. Negative 20 divided by 10 gives us a negative 2 meters per second squared. It is negative. This is slowing down. Negative numbers means you are slowing down with acceleration. And the last one, the bus you're riding on is slowing down for a stoplight. It was initially traveling at 18 meters per second. Stops in 8 seconds. It's time. The stop means it's the final, and again, that's going to be 0 meters per second. So it's going to be 0 minus 18 divided by 8. Oh, that's a weird number. So negative 18 divided by 8 is going to be a negative 2.25 meters per second squared. Again, that is decelerating and slowing down. All right, your job is then to work on the next set of problems. They're pretty much the same thing. I've gotten rid of the pluses and minuses there so they're a little easier to do for you. And you can hand those in to Mrs. Cooley.